And I am going to share my screen with you. Let me start from the beginning. All right, so most of you, all of you who are here now have been here before, but just in case, the enrollment code is there. Please write it down so that you can enroll in our summit class. So today's lesson, comparing data representations. Remember, this is a continuation of what we did last week. Good morning. The objective is to create a graphic representation of data. And that just means we're going to be creating graphs. And again, the standard is there. That is the standard according to the state of Pennsylvania that we need to cover in this course. So our agenda, as usual, we're going to have a short community meeting. We are going to do the warm-up. And I promised you all that we would do the graph of data in 2 ways from last week. There it is. And then our lesson is going to be comparing data representations and what we need to look for. We're going to practice matching histograms to dot plots. And then when that piece moves. All right. And so the assignment will be the cool down, and it will be due on Friday. So let's get with it. So community meeting question. If you were given a chance to be immortal, would you take it? Why or why not? So you're going to live forever, forever, ever, forever, ever. Would you take it? Why or why not? I'm going to check the chat in a minute. Anybody chatting me? Nobody's chatting me. Immortality, what you think, ladies and gents?
No.
Wait a minute. iPhone. Tell me who you are in the chat. Okay, I just see iPhone. I just want to make sure I have attendance right. Why not, Quay Quay?
Because one, I would have to see the same people. I don't like.
Well, no. If you're immortal, oh, hi, Dej. Thank you. You wouldn't see the same people because you're immortal. So you would actually, you would continuously see new people because you're here.
But still, I don't like people. So why would I want to continue to see people? Like, what? No.
All right. Okay.
My place, I'd be good, but no, not to just continue to see people and deal with the attitudes. No.
Okay. All right. All right. Oh, anybody else? Let me check the chat. Anybody else chatting me? If you were given a chance to be immortal, would you take it? Why or why not?
I feel like I wouldn't take it and then I'm going to regret it because I'm not going to have a human life.
Okay. 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 Anybody else? All right, teacher response. I would not. And to me, because everybody I love would be dying around me. And at some point, I wouldn't have anybody who could really relate to me. You know what I mean? Because all of the people who would have been able to relate to me would have already passed on, and I'm still here. Now, so let me see. Okay, no immortal. Oh, because I will watch you. Yep. Yeah, exactly. I agree. Oh, that's cool, Deja. Uh-huh. Oh, okay. No, I'm sorry you aren't. You will live on, but not in that body. All right, anybody else? There's some other people on here. What you thinking? Would you be immortal? Now, just to play devil's advocate, if you were immortal, you would be like a walking history book because you would have seen so many things. You know, you would have seen so many things. Like right now, I know I've seen a rotary phone, a push button phone, and now a cell phone. You know, so in my time, just alone in the 55 years I've been here, you know, so those things have changed. So if I was immortal, oh my gosh, I may be able to be here when you can transport like on Star Trek. You know what I mean? So that could be a cool thing about being immortal. I'm just saying. Two kids in the street phone. You're right. Oh, but yeah. So I mean, you know, so it's some good and bad. But I'm standing by what I initially said. I wouldn't want to be immortal because you know I wouldn't want to see all my people, like you said, get old and pass away. Anybody else have any thoughts on this? And you can, if something comes to you as we go through, you could throw it in the chat. But yeah, the question, and now, just to throw a little something else in there. So all of you gamers, you know, they want, what do you think about AI? Because that, for some people, they feel that that's how they can gain their immortality. They want to have all of their like thoughts and memories and everything transferred into a computer that somebody somewhere, I'm sure, is working on making it as human-like as possible. So that could be down the pike. I'm just saying, maybe not in my lifetime, but could be in your lifetime. Because I personally believe that all of the things that we see, somebody is working on. Like when I was little, it was the Jetsons. Well, now we have some form of what the Jetsons talked about in CDs. Because I can put in a CD and we have holograms where you can project it and it looks like something's there. All of that was on the Jetsons. So in the 60s and the early 70s, that was a cartoon. But now in the 2000s, that stuff is reality. So somebody somewhere is working on it so that you can be immortal. Just know that. Okay? So again, anybody else, if you had a chance to be immortal, would you take it? And of course, defend your position. Why or why not? All right, darlings. Work time, work time. So last week we talked about the 3 plots. We did a review of them: a histogram, a dot plot, and a box plot. And I promised you on Friday that this would be your warm-up. So we are using the set of data there presented. And I want you to do 1 and 3. And I will present 2. And I'm only saying don't do 2 because our data set doesn't have any repetition. So there isn't really going to be a whole lot in the dot plot. So I want you all to create a histogram and a dot plot of the data. And I have 9:40. So I'm going to give you 10 minutes. So that's 5 for each. So at 9:50, we're going to talk about it. I want you all to describe what you see, and I'm going to use my Google board here to write what you're telling me, and then we'll talk about it. Good morning. We are doing, we are on the warm up. We are creating a histogram and a box plot using the data set that you have in front of you. And we are going to review it in about 7 minutes. So please do your histogram and the box plot. We have about 5 more minutes. We're going to talk some math. Everybody's good. Nobody's asking any questions in the chat.
I am. Hey, I'm confused.
Oh, okay. Well, girl, speak up. Why are you confused? What you need?
I need help. I told you what how you get the cute. I gotta look at my picture.
Remember that the
Huh?
you said you found what Q2 first, right? Absolutely.
Q2, which was 12.
All right. All right. So what? All right. So now, so when you found Q2 split your data into two parts, right? Upper half, upper half, and lower half. Correct. All right. So now let's think about this. You split the data in half, right? So that's here. Remember, it's median, median, median.
I can't see if you're showing something.
I'm showing you my arms. You can't see me?
No, it's still on the warm.
Oh, it's on the share. Okay. Can you see me now? Wait a minute. I'm gonna stop the share. Okay.
Yeah, I can see you.
Okay, so you had the data set, right? You cut it in half. So Q1, remember, only deals with this part of the data, the lower end.
Right.
And remember, the box is made up of middles. The middle of the lower half, the middle of the data, the middle of the upper half.
Okay.
Yes?
Okay. I think about it.
All right. All right. Let's see. Somebody else talking. Oh, okay. All right. So just hang in there, see if you can follow. And then maybe you should join me in the lab this afternoon and we can do some clarifications, okay? Will that work? All right, we got one more minute. Then I want to have some discussions, please. All right. All right, good people. Talk to me. So, tell me what you did for the histogram. Some brave soul. What did you do? First of all, in a histogram, remember, ladies and gentlemen, you should do what to the data? Put it in
Order.
All right, you can put it in order. All right, so what's the order?
3. No, my fault. But no, yeah, 3, 5, 7, 8, 12, 13, 14, 18, 21.
18, 21. All right. Okay. So now you've done that. What next? Anybody?
This for the histogram first? Or the bottom?
Yep. Let's do the histogram first. And it's okay that you have the data in order for the histogram. That's fine.
All right, hold on. Let me do the drum real quick. Hold on.
Anybody want to share theirs on the screen?
Hey, yo, stop it.
I'm just asking.
Not you, Miss Hicks. My fault.
Oh. Look, sometimes I don't know. All right, so somebody tell me what you did. We know what a histogram looks like. So for those who may not remember a histogram is continuous. It's a continuous graph. There are no spaces. It is akin to a bar graph. Anybody want to share what they did? Come on. Come on. All right. Well, anybody at least want to tell me what are your bins? How did you group the data? Oh, you breaking my heart. Let me see if somebody's chatting me. I hope you are. Nobody's chatting me. Okay. No, nothing. All right. Well, I hope this is warming you up for some conversation later. So, looking at the histogram, I agree with Quay. She put the data in order. But now remember, in a histogram, ladies and gentlemen, you are grouping the data, remember? And it is continuous. So you see, so my bins, I made five units deep. Excuse me. I made my bins 5 units deep. So 3 is my minimum. I went up 5. Remember, the end point of the previous bin is the beginning of the next bin. Again, it is continuous. So when we look at what we put in the bins, we see that there is in the first bin, and I'm going to help you all out on this slide. Oh. So the bin is 3 to 8. So again, inside of it goes the numbers 3, 5, and 7. And there is an error on here. Does anybody see the error? Because these numbers aren't those numbers. Do y'all see that? You see these numbers don't match?
What error, Miss Hicks?
8 and 12. This bin. So I'm getting ready to change it. I don't know what I was doing. Oh, maybe I was going to change the baby. I don't know. All right, 13 is this. All right, wait a minute. Ladies and gentlemen, we have hit a snafu here. 14. How about this? Take this out. So now, in the bin from 13 to 18, we have 14. 14 and 18. No, we don't. We have 14. Wow. I would have to recreate my graph, ladies and gentlemen. 18 and 21. All right, so we are going to look back at this slide. And I swore I had it together. All right, so these are the data. So in this bin, 3 to 8, we only have 3, 5, and 7, because remember, 8 gets counted in the next bin. So those are our 3. So in the next bin from 8 to 13, we have 8. There's the other one. Oh, sorry. We have 8, 12, and 13. We have 8 and 12. 13 goes here. All right. That's screwed up real bad. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. All right. So we have the terms in the bins. So now I am going to draw the graph, because the graph that I have included is not going to work. So I am going to put my bins here. 3 to 8, I have 3. 8 to 13, I have 2. 13 to 18, I have 2. And 18 to 23, I have 2. All right, so I'm going to stop the share so you can see. All right, so can you all see this board? Can you see this board?
Yes.
Okay. All right, so we're going to straighten this out. So here are the bins. And again, my bins are 5 units apart. When you construct your bins, remember, you don't want them to be too small because there'll be too many. And you don't want them to be too large because you won't really have a lot of you won't have a lot of towers, so it won't be distinguished enough. So here are our bins. So now remember, across the bottom we'll have our bins, and up the side we'll have our frequencies. So our bins, they don't start at 0, they kind of start at 3. So 3, 8, 13, 18, and 23. Now, you see that this last bin, although it goes to 23, Our highest number is only 21. Okay, so from 3 to 8, let's see, we can go up. And again, when you do your graph by hand, it is a sketch, but try to space your numbers equally so that you will get a halfway decent graph. Okay, so bends are across the bottom. The frequency is up the top. So between 3 and 8, we have 3. Between 8 and 13, we have 2. Again, no spaces. No spaces. They are connected to show that the data is continuous. 13 to 18, we have 2. And 18 to 23, we have 2. So the graph should have one high tower, one high bar up to 3, and then the other 3 should have been even. Yes? So if that is not what your graph looked like, jot that down. And again, if you want to know what was in the bin, this is 3, 5, and 7. This is 8 and 12. This is 13 and 14. And this will be 18 and 21. So again, in this instance, you see 8 gets counted in the second group, not the first. 13 gets counted in the third group, not the second. And 18 gets counted in the fourth group, not the third. Okay? Questions, comments, concerns? Okay, and again, I apologize about that data. I probably had 2 problems going on in my head at one time. My apologies to you. All right. And if you need me to show the board again, just let me know. All right, so I'm mad about that graph. I had to change that. Okay. So now the dot plot straight across. That's why I said, because there are no repetitions, this is what the dot plot would look like. Okay, there is one of each term. So it's not a whole bunch of action going on the dot plot. So that wouldn't help us. But now we come to the box plot. So if the data is in order, we identify the minimum value, which is the lowest, and the maximum value, which is the highest. Now we start talking about the quartiles. So you find the median of the data set itself first, because the median of the data set then splits the data into 2 parts. The lower half, which is 3, 5, 7, and 8, and the upper half, which is 13, 14, 18, and 21. So now, Q1, and that was the question Quay had. She said she forgot a little bit. But so Q1 is the median of this first portion of the data. Now, remember, if it's an even number, how do we find the median? If it's an even number of terms, how do we find the median?
would be the middle number, right? Correctly.
It would be the middle number, correct? But there are 4 terms. So is there a middle number?
Yeah.
So how do you find it?
All right, so I need to hold you. I put my numbers in order, or being in order. So I kind of like X'd out all the joins out until I got 12.
Okay, that's the median of the data set. I agree. We are now trying to find quartile 1. We are trying to find the middle.
Oh, that's what I'm saying. Ain't that's how you get quartile 2, right?
That's quartile 2, yes. And I agree with you. I am asking you, how did you find quartile 1?
Oh, how I find 1? Oh, I don't know. I ain't get
Somebody, we have a good number of people in the class.
Then you had to add to get that.
What you add?
Hold on.
Is somebody looking at the slide? The crowd fell silent. What happened, people?
My internet keep wanting to know. There's not behind 1. You got to add the 5 plus 7, right?
Yes.
And then
I put it right down at the bottom of the slide. When you have an even number of terms, there is no physical middle. So you will take the middle 2, add them together, and divide by 2. So you find the average of the middle 2. So for Q1, 5 plus 7 gave 12. 12 divided by 2 gave 6. And what you did to the lower half, you will then do to the upper half. And same thing, there are 4 terms. So we take the middle 2, 14 and 18, which is 32. 32 divided by 2 is 16. So when I was saying to you, if your median is closer to quartile 3, place it that way. So here is how it should have looked. 3 is your minimum. Quartile 1 is 6. Quartile 2 is 12. Quartile 3 is 16. And the maximum is 21. So the data stretches. 3 is the lowest, 21 is the highest. The middle of the data itself is 12. So now we have the data in 2 parts. So we want to know, again, the middle of the low end. So that's 6. And then we want to know the middle of the high end. That's 16. But you see the placement of the median closer to quartile 3 than it is to quartile 1, because 12 is closer to 16. Make sense? So when you place your placement of your quartile markers makes a difference. Okay? So if we moved the median of the data set down here to 6, well, that wouldn't make sense, because the difference between 6 and 12 is 6. But the difference between 12 and 16 is 4. So your median should be closer to the middle of the high end versus being close to the middle of the low end. Make sense? A little bit, kinda?
Yeah.
We need to practice that, ladies and gents. We need to practice box plots.
No, probably histogram though. You can't. Again,
write this in your note. with the annotations so that when you look back on it, you will have a point of reference. Okay? If it makes sense to you in your notes for Q1, circle this the lower end, 3, 5, and 7, so that you understand where this equation, 5 plus 7 divided by 2, came from. Okay? If you need to make your notes that specific, okay? Or maybe in your notes, you put a bracket and you put average or something like that. Whatever is going to help you remember how to construct a box plot. That's what I want you to put in your notes. And again, remember, this is the order that your numbers go in. The minimum, then the middle of the lower half, then the middle of the data, then the middle of the upper half, and then the maximum. And you get those 5 numbers in steps 2 through 5. All right, with that? Okay. So we have about 9 minutes, so I will introduce the lesson. So here's what I wanted you to get from the warm-up. In the dot plot, you see each term. It's clear. You could say there is only 1 8, there is 1 14, there is 1 21. In a box plot, that's your 5 number summary. So that just kind of gives you the averages. But again, from the box plot, you can still answer some questions. You can answer the range of the data because you know the maximum value is 21. The minimum is 3, so you can find the range by doing a subtraction. You also know because of this box, and you might want to add this to your notes, this box between Q1 and Q3, that is 50% of the data. Because remember, they are called Qs because they are quartiles. There are 4 parts. So just like a dollar has 4 quarters, 4 parts, quarter 1, quarter 2, quarter 3, quarter 4. Okay. But 50% of the data then lies between 6 and 16. So, and again, this is all of the information that you can get from a box plot. So again, from a box plot, please add it to your notes wherever you have box plots. You can tell the range of the data. You can tell the middle of the data. You can tell where 50% of the data lies, and that is called the interquartile range, IQR, and we'll talk about that a little more. But the IQR is the interquartile range, and that tells you the distance between, or the range between, the middle of the low end of the data and the middle of the high end of the data. Okay, so again, box plot, you can tell the range of the data itself. You can tell the middle of the data. It is clear. You can tell the interquartile range, and you can, that just means you can tell the range of 50% of the data, because this is the low end, this is the middle of the low end, this is the middle of the high end. So you can then tell between how much data or how much space is between the low end, the middle of the low and the middle of the high. And then in a histogram, data is grouped into equally spaced bands. So in that, we can't talk anything about individuals. We don't know about individual totals. If we did not see the data set and we just saw this graph, we wouldn't know exactly which terms between 3 and 7.9 are in this first bin. All we know that there are 3 terms. Same thing between 8 and 13. We don't actually know what the values are. We just know that there are 2 of them. And they could be, it could be 2 9s, it could be a 9 and a 10, it can be a 10 and a 12. We don't know that. So for a histogram is better when you have large data because, again, you are grouping it together. And again, we cannot tell about any individual term because the data has been grouped. Questions, comments, concerns, repetitions? Do you need me to repeat anything from any of the 3 representations? And again, we will continuously repeat the same. I will repeat the same characteristics. You know, I will have the same conversations just so that, again, when you see it, you'll be like, oh, okay, I can do this. I understand this. All right. Now, this was our lesson, which we probably will not get to because our time is drawing nigh. But here is just a preview. We will be comparing box plots to histograms. These 2 represent the same set of data. Okay? They represent the same set of data. So in our comparisons, we are going to check shape. We are going to check max and mins. We'll estimate the median. And then we're going to look for outliers. Because, again, like I said, these 2 graphs represent the same data. And we are going to talk about how, if we had to, we can figure out that these 2 are actually partners. Okay? Make sense? A little bit? Oh, the crowd fell silent. Okay, but that's okay. Because again, this is a new concept. So we will, on Friday, we will start with the comparison. I will give you a warm-up to create a box plot and a histogram of the same data again. Okay, so I'm telling you now, that will be the warm-up again. And then we will go into our lesson on comparing box plots and histograms. So with that, I am going to stop.